Hello friends, good evening. Before we start, let's have a attendance taken. I'll just call your names and on the right hand chat window, which you have on the right hand side at the bottom, there you have just say yes. Sapna, okay. Rohit, okay. Ashwini, yes. Priya, Priya, I think Priya has not joined in yet. Okay. Swapnil, yes. Okay, except Priya, all of you are there. So we can start this session. But before starting, how are how are you all feeling today? Good? Right on the chat window. Okay, good, good. Sapna, you say you're not okay. Why? Okay, okay. You belong to Chennai and there are problems in Chennai. Water problems, right? Rains, heavy rains. Anyway, it's it will phase out. It's just temporary problem. Okay, so before we start again, what I would like you to do is keep paper and pen on your side because we'll be doing some exercises online together. We'll be doing it together. I will also solve and you will also solve the problems. Okay, so shall we start? Okay, good. So today we are going to do time and distance, and in particular, time and distance is a vast subject, and this particular time and distance formula and all is applied in vast areas. It can be simple time and distance, it can be train, it can be boat and stream and other areas. Today we will cover only the train area, only the train area. We will take up some problems. First of all, we will understand what different train situations are, and based on those situations, we will solve some problems. Okay? Okay, fine. So time and distance. Can you tell me what is the classic formula for time and distance? Can you write just, yeah? Yeah, okay, okay, yes. Yes, Rohit, it's speed is equal to distance upon time. Now, what does it mean? Let's understand that. Speed is equal to distance upon time. Am I audible? Okay, okay. And are you able to see what I am writing or is it very blurred? Okay, you are able to see. Fine. So this we can write as d by t. So classical formula is S is equal to d by t. Now we know, just let me clean this. This gets cleaned. Now you know that speed is directly proportional to distance. What does this mean? This means that time remaining constant, if you have suppose a distance, this is your distance d, and time remaining constant, suppose you have to cover this distance in 30 minutes, you will run at a speed s1, okay, and let's say this is d1. Now I change it to d2. okay, where d2 which is greater than d1. Okay, time remaining constant. You have to cover this d2 distance also in the same time, that is 30 minutes. So what will you do to the speed? Will you increase the speed or will you decrease the speed? Mind it, time is same, distance has increased. So to cover greater distance in the same time, you will have to increase the speed, which is S2, which will be greater than S1. This is what means by speed is this one. Speed is proportional to distance. Okay. Let's see the other thing. The what is happening? Let me clean. Yeah. Okay. Now let's say speed is, kindly bear with me. What is happening? Yeah, fine. Speed is proportional to 1 by t, which means speed is inversely proportional to t. This means that suppose you have a distance d and keeping the distance same, if you have to cover in different times, which means suppose you go with s1 speed and t1 time, you cover this distance. Okay. Now, in the second stage, suppose you go with S2 speed and this S2 is greater than, less than S1, or S2 is greater than S1. If S2 is greater than S1, what will you do to T? Will you increase T1 or will you decrease T1? Distance remaining same. When distance remaining same, if I have to travel and at a higher speed, of course I will reach there in a lesser time. If T2 is that time, then T2 will be less than T1. So you see, speed you have increased, but time has decreased. So speed is inversely proportional to time. Understood? Please write in chat window or we'll explain it again. Okay, good. So now I combine both of them. What will happen is speed, if I have an equal to sign, because earlier it was proportional, if I have an equal to sign, I will write K d by t. K is what? K is the proportionality constant. But we know that speed is equal to distance upon time, whereas that's a classical formula. So where does this K go? By experiment, it has been found that K is always equal to 1. Okay? K is always equal to 1. If K is equal to 1, then you get this formula, speed is equal to distance upon time. This is how this formula has been derived. Okay, clear up till now? Any confusions? Okay, good, good. So the other thing which we have to see in time and distance is the units. Speed unit is mostly in meters per second or kilometer per hour. Okay, Time can be in seconds or can be in hour. Then distance can be in meters or can be in kilometers or even miles also. Fine. So it is important that the units have to be matched on the left hand side and on the right hand side. So in this formula, when we have S is equal to D by T, the unit of this should match with the unit here, which means if S is in kilometer per hour, distance should be in kilometer and time should be in hour. If S is in meters per second, distance should be in meters and time should be in seconds, or vice versa. If D is in meters and T is in seconds, speed should be meters per second. Or D is in kilometers and T is in hours, then speed should be kilometers per hour. Okay, clear? Okay. Now we'll see some conversion factor. If I have sorry, again I make this mistake, 1 kilometer per hour. Now if I have to convert it to in meters per second, what will I do? 1 kilometer at the numerator portion will become 1000 meters, right? And 1 hour, if I have to convert to seconds, it will be 60 into 60. Okay. Now I start cancelling. I will get what? 10 by 36. Again I cancel this. This will be 5 by 18 equal to, sorry, 5 by 18 meter per second. Now this is the classical conversion. If you have to convert 1 kilometer per hour in meters per second, you have to multiply the figure by 5 by 18. Vice versa. If you have to convert meters per second to kilometers per hour, you have to multiply by what? Tell me. Yes, Rohit, Ashwini, anyone? Yes, 18 by 5. You have to multiply by 18 by 5. Great. So we have understood the unit conversion. We have understood the formula, how the formula has come. Now this formula S is equal to D by T can be used in different applications. It has many applications. Like train is one application. This boat and stream can have another application. There can be many applications where this can be applied, this formula. But the application depends on the different situations. We will just cover today the train situations. Okay, fine. Now I will go through some presentations. Typical situations in train problems. Okay. Let's see first thing. A train crossing a signal. Okay, you must have seen signals. Okay, this situation can be same as a pole, a train crossing a pole or a signal. Now let's say this: a train is coming, and from this point it will start crossing the signal. See how it will happen. At this point, it has crossed the signal. Now, can you tell me how much distance the train has traveled to cross the signal? Yes, right on the in the chat window. Yes, yes, Ashwini. It's 50 meters. 50 meters is what? Is the length of the train. That is the distance crossed by the train and it has to cross a signal. That is the distance traveled. So here in this case, d will always be equal to the length of the train. So train travels 50 meters before crossing the signal. That is, distance is 50 meters. Signal width is considered negligible in this case. And the situation is same when a train crosses a stationary pole or a stationary human being. Anything which is stationary and which doesn't have a width, the situation will remain the same. Okay, fine. Let's go to the second situation. Now, train crossing a platform in a station. You must have traveled by train. You must have crossed a lot of platforms. This is the same situation. Train starts, comes here. From this point, it will start crossing the platform. Now, watch closely how much distance it will travel. Got it? What is the distance train has traveled? Okay. No, Swapnil, it's not 100 meters. Let us see once again. How much? Yes, it is 150 meters. The distance traveled by train to cross the platform is 150 meters, which means the length of the train plus the length of the platform. Okay. So the train travels 150 meters before crossing the platform. That is, distance here is 150 meters. And the situation is same when a train crosses a bridge. It's the same situation where you have to add the length of the bridge and the length of the train or any other stationary object which has some width. And that width has to be added to the length of the train. Clear? Okay, let's go to situation 3. Two trains moving in opposite direction. You must have traveled in trains. Okay? And how do you feel when a train comes from the opposite side? Two running trains. You are traveling in one train and the other train comes from the opposite side. How do you feel? Do you see any change in velocity or speed? Yes? Yes. Yes. The speed seems to be very, very fast. This is what the main crux is here. Let's see. Now these two trains are coming from opposite directions. At this point, they will start crossing each other. One train is 80 meters long and traveling at 80 kilometers per hour, and the other train is 50 meters long and traveling at 70 kilometers per hour. Now tell me, how much distance each train has traveled to cross the other? Yeah, let's, okay, yes, it is 130 meters, which is the addition of length of both the trains. And at what speed one train crosses the other? No, it is not 80. No, no, it is actually 80 plus 70. It is 150 kilometers per hour. So one train crosses the other at a speed of 150 kilometers per hour. And this is why it seems to you that the other train is crossing very, very fast. At that time, what happens is you are considered to be stationary and your speed is also transferred to that train, the other train. And your speed is added to that train. Okay, so in this case, the speeds get added and the distance traveled by each train is the addition of the length of both the trains. Okay, so each train covers a distance of 130 meters before crossing the other. 130 meters is what? Summation of addition of the length of both the trains. And the speed at which any one train will cross the other is 150 kilometers per hour. This is also summation of both the speeds of each train. So here it will be 150 kilometers per hour. And the situation is same when train crosses any other running object from opposite side. Any other running object, if you cross, suppose somebody is running from the other side, opposite side, he or she will see running very fast, which is not his or her actual speed. But because of the situation, the speed increases, the crossing speed increases. Okay? Okay. Let's see the situation 4. Two trains moving in same direction. Here, what happens is one train crosses the other. The train with higher speed will cross the train which is running at lower speed. But the crossing speed will be very slow. You must have noticed, while if two trains are going together, and certainly if both the speeds are almost same, you can see the other train, inside the other train, what is happening. There's a very interesting. Do you read Agatha Christie novels? Okay, you have not read, but Agatha Christie is she had written a lot of mystery novels, and one of the most famous mystery novels. She she is one of the remembered as one of the most famous mystery novel writer. Now, in one of her novels, a murder was committed on one train, but the other guy was traveling in the other train who was the witness to this murder, and he said he pointed out who was the murderer. How could he do that? Because both the trains were traveling in the same direction and almost at the same speed, and he could see clearly what is happening in the other train. Okay, so he could see the murder. Okay, now in this case, let's come back to this situation. In this case, what will be the distance traveled by one train to cross the other? It will again be summation of both the length of each train. Here it is 80 and 50, so the distance traveled by the faster train to cross the slower train is 130 meters. What speed it will cross? Here the speed will be the difference of both the speed. And difference is 80 minus 70, that is 10 kilometers per hour. So faster train will cross the slower train at a speed of 10 kilometers per hour. Okay? Each train covers distance of 130 meters before crossing the other. The speed at which any one train will cross the other is 10 kilometers per hour, which is a difference of both train speeds. The situation is same when a train crosses any other running object toward the same direction. Okay? Are you clear about these concepts? Because these concepts are very necessary. Are you? Can you write on your chat window? Okay. Okay. Yeah. Okay, great. So now from this point onwards, we'll move towards solving the problems. Typical train problems. Okay, ready? Keep your pen and pencils ready. We'll start solving the problems. Let's see, this is the first problem. The problem says, just give me a couple of seconds. The problem says, find the length of the bridge which a train 130 meters long and traveling at 45 kilometers per hour can cross in 30 seconds. Okay, now let's do this. Let's do like this. Let me change the color so it will be clear, more clear. Now let length of bridge is equal to sorry, is equal to L meters. So now what is the distance here? The, the situation is same as train crossing a platform. So the distance will be 130, which is the length of the train plus length of the bridge in meters. What is the time? Time given here is 30 seconds. Okay. What is the speed? The speed given here is 45 kilometer per hour. Now you see here, your distance is in meters, your time is in seconds, but speed is in kilometer per hour. Units are not matching. So this needs to be changed to meters per second. What do? I do S is equal to 45 into the factor you remember 5 by 18. Okay. This is 2, this is 5, so it is equal to 25 by 2 meters per second. Now your units are matching. Okay. So what do I do now? Let me draw a line here so that it becomes more clear. I will do it here. Now putting the same, S is equal to what? D by T in this formula. S is how much? 25 by 2 is equal to distance is 130 plus L by how much? 30. Time is 30 seconds. Right? Now what I do is I just start simplifying. Okay? So it becomes 25 into 15 is equal to, sorry, is equal to how much? 130 plus L. So this is equal to 375 is equal to 130 plus L. So L is equal to 375 minus 130 is equal to how much? Is equal to 245 meters. What is L? Yeah, this L is what? This L is the length of the bridge. So the length of the bridge is 245 meters. This is what the answer is. Understood? Great. Great. So let me go back to this. So this was the problem. 245 meters is the answer. Here you see there is another 24500 centimeters is also the answer. Both are same, 245 meters and 24500 centimeter. Generally, you will not get both the answers, but this is just for demonstration purpose that units can be different in the answers. You have to look for that. Okay? Okay. Let's go to the second problem. Two trains, each 100 meters long, moving in opposite directions, cross each other in 8 seconds. If one is moving twice as fast as the other, then find the speed of the faster train. Let's do this. Okay. Let me clear this. Board should be clear. All right. So now you have a plane. All right. This is what the problem is. Two trains, each 100 meters long, moving in opposite direction. Now, both the trains are moving in opposite direction. We have to see that situation. Cross each other in 8 seconds. If one is moving twice as fast as the other, then find the speed of the faster train. Okay. Let's say let the speed of slower train is x meters per second. Then the speed of faster train is what? It will be 2x meters per second. Right? Okay. Now what is the distance here? Distance is equal to, just recollect that situation when two trains crossing each other from opposite direction, the lengths are added. Length of each train is added. So 100 plus 100, which is equal to 200 meters. Okay. What is time? Time is equal to 8 seconds. What is speed? Speed is equal to, in this case, what will happen? Both the speeds will get added, which means there is, you have x plus 2x is equal to 3x meters per second. Now units are matching. I don't need to do any conversion. Now putting in the formula, s is equal to d by t. 3x is equal to 200 by 8, which is equal to 25. So x is equal to 25 by 3 meters per second. Let's convert this into kilometers per hour. What will I do? X is equal to, now I am converting it to kilometers per hour. So it will be 25 divided by 3 into 18 by 5. Right? When you convert from kilometer per hour to meters per second, you multiply by 5 by 18. When you convert from meters per second to kilometers per hour, it is 18 by 5. Okay. So now if I do this, it will be 5 here, it will be 6 here. So is equal to 30 kilometer per hour. Okay. Now what is x? X is the speed of the slower train, right? X is the speed of the slower train. But we have to find the speed of the faster train. So speed of faster train is 2x. 2x is equal to 2 into 30, which is equal to 60 kilometers per hour. So the answer is faster train is moving at 60 kilometers per hour. Is it okay? Understood? Any confusion? We can do it again. Oh, okay, great. Very good, very good. You all have understood. Yeah, yeah, okay. Am I going too fast? No, okay, fine. Fine, so now we'll clear this. And go to third problem. So here if you see, the answer is 60 kilometers per hour. I would like you all to do this problem. This is similar to the previous problem. Only the change is that both the trains are moving in the same direction and we have to find the speed of the slower train. Okay, I give you 2 minutes. Do it and write the answer in the chat window. You'll have to assume that the first train moves at x meters per second and the second train will move at 2x meters per second like the previous one. Okay, if you get answers in meters per second, try to convert it in kilometers per hour. Okay, Swapnil. Yeah, okay, it's 90 kilometers per hour. Great, great, great. The answer is 90 kilometers per hour. It's also 25 meters per second. Both the answers are correct. What about other people? Sapna, Rohit? Okay, Rohit. Great, great. Your answer is correct. Okay. Have you understood this problem? You want me to solve? Write in the chat window if you want me to solve this problem. Okay. Okay, okay. Okay, I'll solve this problem. Okay, fine. So here the problem comes. Now let us start doing the solution. Okay. Now let the speed of slower train is equal to how much? X meters per second. And what is the speed of the faster train? Speed of faster train is equal to how much? 2x meters per second. Okay, this is given in the problem. Okay, now here what will be distance? D will be 100 plus 100 again is the situation. Both trains traveling in the same direction. You have to add the distance, the length of the train, which becomes 200 meters. Okay, Time is how much? 8 seconds. And speed is what? Since both the trains are moving in the same direction, the speed will be difference of both the speeds, which is 2x minus x is equal to x meters per second, which means that the faster train will cross the slower train at x meters per second. Okay, now let's solve this. So here I have x is equal to 200 by 8 is equal to 25 meters per second. Okay, if I have to convert it to kilometers per hour, I'll have to multiply by 18 by 5, right? This is the magic factor. Okay, you cross this, you get 5, so it is equal to 90 kilometer per hour. Okay, so the answer is 90 kilometers per hour. X is what? X is the speed of the slower train. Since x is the speed of the slower train, then the speed of the slower train is 90 kilometers per hour. Okay, understood? Okay, Ashwini? Yeah? Okay, fine. Good. So we remove this, rub it off. Let's take the other problem. So here you see the answer is 90 kilometers per hour and 25 meters per second. Both are same. If you convert 25 meters per second, you get 90 kilometers per hour. Let's see this problem. A train speeds past a pole in 15 seconds and a platform 100 meter long in 25 seconds. What is its length? Okay. Let's do this problem. Okay. So here you see a train speeds past a pole in 15 seconds and a platform 100 meters long in 25 seconds. What is its length? We have to assume that train crosses the pole and platform at the same speed. That assumption has to be taken. Assume train crosses pole and platform at same speed. Same speed, sorry, which is x meters per second. Okay. Now this is the speed, right? Now let's see the situation of pole. In pole, the distance is how much? It is the it is the it is the length of the train, right? It is crossing the pole, so it is just length of the train. So here I can write x, which is speed, is equal to L. L is the length of the train in meters by 15 seconds. This is the time taken. This is your equation 1. Okay. Now let's see the platform situation. Here speed is equal to, now what is the distance here? At this point, the train is crossing the platform. So it will be the length of the train plus the length of the platform by time taken to cross, which is 25. This is your second equation. Okay. Understood up till now? Yeah. Right in the chat window? Yeah. Okay, fine. So now from equation 1 and 2, I can clearly say L by 15 is equal to L plus 100 by 25, right? Okay, so this becomes 3. I'm taking 5 as the factor. This becomes 5. So cross multiplication 5L is equal to how much? 3L plus 300. Cross multiplication. Okay, so if you bring this on the right hand side, so it will become 2L is equal to 300. So L is equal to 150 meters. What is L? L is the length of the train. So length of the train is equal to 150 meters. Okay, understood? Clear? Yeah, good. Good. Now we'll take up the last problem. Before going there, let's clear this because we have to do another problem here. Okay, now let's go back here to our presentation and see. So the answer is 150 meters. The length of the train is 150 meters. Now let's take this problem. It's the last problem of today. For today. Now, sorry, you got the answer, but it's okay. Now this is a very interesting problem. Okay, let's say this. Two stations A and B are 110 kilometers apart on a straight line. One train starts from A at 7 a.m. and travels towards B at 20 kilometers per hour. The other train starts from B at 8 a.m. and travels towards A at speed of 25 kilometers per hour. At what time will they meet? Definitely they will meet somewhere. At what time? That is what has to be found out. Okay. So let's say this. This is your B. This is your A. Okay. This whole distance is 110 kilometers. Okay. A train starts from here at 7 a.m. at a speed of 20 kilometer per hour, right? And another train starts from here at 8 a.m. and it runs at 25 kilometer per hour. Now this is the situation and it says at what time they will meet. Okay. Can you say logically what time they will meet? Okay. Okay, I'm not getting any answer. Anyway, let's do it mathematically first. Then we'll talk of logically. Let us say something like this, that this is my x hours. Okay. This is my, sorry, x hours. What it means is, the train from A meets the train B after X hours. After it starts from 7 a.m., it travels for X hours and then it meets B. Okay. Now let's see how we do this. Suppose this distance is D1 and this distance is D2. Okay. So what will be the distance D1? Will be equal to speed into time. Speed is what? 20 kilometers per hour and time is X hours. So it will be X, 20X, right? 20X kilometers if you see the units. Okay. What will be D2? This D2. Okay. To calculate this, we have to find out or understand what the time this time will be. Now, if this takes X hours to reach here, train from A, how much time will train from B take to reach this point? Yeah, tell me, write it. Great, Sapna, great, great, great. It will take X minus 1 hours because this train starts at 7 a.m. and this train starts at 8 a.m. There is a difference of 1 hour. Okay, and multiplied by 25, which is your speed. So here D2 is equal to 25 into X minus 1. Now we know D1 plus D2 is equal to 110. See here, 110. Okay. Putting this equation, we have how much? 20x plus 25x minus 1 is equal to 110. Can you solve it and tell me what is x, value of x? Do it. Yeah, yeah. Yes, yes, Swapnil. It is x is equal to 3 hours. Quite fast. You did it quite fast, right? X is equal to 3 hours. So if x is equal to 3 hours, what time both train will meet? Start at 7 a.m. This x is 3 hours, so they will meet at 10 a.m. Understood? Ah, great, great, good. So here we come to the end of our this session. Hope you have understood, and in couple of hours you will receive some more problems, exercises on your mail, which you have to answer and send us back latest by day after tomorrow. Okay, if you have any queries, you can write to our mail ID, okay, and it will be promptly replied, or you can call also. But I think writing is much better because you can explain much better, and it goes directly to the faculty, so your answers will be immediately answered. Okay, so for this, your answer is 10 a.m. Right? Okay, guys. Thank you very much for this session. I really appreciate. Have a nice day and good night to you all. Thank you.